And we're going to take a look today at transformations of trig functions, okay? I'm going to take you through the different transformations of the sine curve, but just so that you know, the transformations for the cosine curve are identical, exactly the same, yeah? So the first thing that you need to know is how to graph the y equals sine x. So it's right here. Remember, sine starts at, well, starts, but at 0 it's at 0. And at 90 it's at 1, and so on. Yeah, remember it's just the unit circle unwrapped. So in this case, the y values. Okay, so this is very similar to the functions unit, yeah? And the first thing to show you is what happens when we change the a, okay? So the number in the front of the whole function. Well, and I'm using autograph here, it's pretty cool. You can see that when I will increase a to 2, what it does is it vertically stretches all the y values, okay? So we're going to record this here, okay? So this is our, and see, I even started writing it on the cos, but it doesn't matter. So it's the vertical stretch, okay? And the fancy word for it is amplitude, okay? And it's just the distance between the minimum and the maximum, okay? Now, if I wanted to make this, for example, negative, you can probably predict what will happen. Think of a table of values. When you put a negative in front of the values, boom, you see that it is a reflection. So it literally just flipped the whole curve. Okay, so that's a. So you just multiply, and again, if you wanted to see, and I'm going to get rid of the minus, get back to where I was. And what I'd like to do now is see what happens when it's a half. Think about that, pause. If you want to, you can even graph it. Okay, and you see now that the distance from the principal axis to the maximum is a half. Okay, so that's a. All right, so now I'm going to go back to 1. We're back to the mother function, or parent function. And we're going to see what happens when we change b. b is a little bit of a tricky one, okay? One of the terms that we need to know, and with the 11th grade, we did this in class, is what a period is, okay? And just remember that the period is the length of one cycle, okay? So right now, our period is 360, right? You see that it takes 360 degrees to come back to where you were and to start the behavior again. Okay, well, let's see what happens when we change b to b2. Okay, so we're going to go up. Okay, so now look at this. When b is 2, the period becomes 180. So what this b is it is basically a horizontal stretch or compression. Okay, now something more to say about it. The other thing that b is it is the number of cycles that we are going to fit in 360 degrees. Okay, so you saw when b was 1, it was just the one cycle in 360. When you have b is 2, then you see that you're fitting 2, okay? And the other thing to notice about it is that when your b here is 2, this is actually a horizontal compression, right? So what you've done is you've actually took the wider graph and you squished it. Okay, so the bigger this number, because you're fitting more cycles, the more squished the graph is, okay? And if I keep going like this, you see, and now my period when b is 4 is 90, right? Because I'm fitting 4 into them, okay? So one more important thing to remember for us is always, always, when you want to find period, and this is a formula that you should write down in your notes and make a big bubble around it, make it obvious. Period is always 360 divided by b, okay? Y divided by b, well, if b is 4, then you're doing 360 divided by 90, then it's by 4, then it's 90 degrees, right? And so on. So just very quickly to demonstrate, well, think about what happens when this is going to be a half. What that means is that you're only fitting half of a cycle in 360. Bam, you see what happens? So my period now the length of a period, 360 divided by a half is 720. So it's taking 720 degrees to cover one period. Okay, so this is all about the horizontal and the vertical. Let's move on. Now it gets easier. You guys have done functions, okay? And now, basically, look at what happens. So I'm dealing with C now, la la la. So look at this, right? All that's happening here is when you're dealing with this number that's inside the bracket, it's going to the right, okay? And of course, if I make it smaller, then it's going to go to the left. So let's use another color here. Okay, this is just a left and right shift. Okay, so horizontal shift. And if you want a fancy name for it, this is called a phase shift. Okay, and I'm going to put the name here because I'm getting out of control over there with the mess. Phase shift. It's the left and the right. Okay, and the last one, so I'm going to change this back to 0. From 360, notice, no change, right? Because before we just had it shifted over. Okay, and now the D. Probably again, think of your functions, probably will come intuitively to you. Oh, look, we're going up. Oh, look, we're going down. Yeah, logish. You're just adding on values to the Y. You're making Y a little bit bigger. So this is just, what haven't we used? Green. So this is just vertical shift, so up and down. Okay, so that concludes this podcast so that I'm not blabbing on for too long, but in the next one I'm going to do a few examples of graphing the transformations. So go ahead and watch that one now. Thanks, ciao.